This is a great problem to illustrate that when you have a velocity versus time graph, you can actually use the area under the graph to calculate the displacement and the distance that a car travels. And it works like this. Go ahead, pause the video and read this question. And now that you've seen what the question says, basically, we're going to go ahead and solve it. So the way we get this is really this straightforward. I want to calculate the displacement of the car. So I have the velocity versus the time. And I actually take the area of this curve, which is positive, of this rectangle here, and I subtract, and since it's a positive rectangle, I'm going to make this positive displacement, and I take the negative area here because it's going backwards, so it backs up. So here the car is going forward at 6 meters per second, and then it actually goes backwards here. And to actually calculate the displacement, I'm going to get the area. So the area here is going to be 6 times 2, which is 12 meters. And here I'm going for 1, 2, 3, 2 to 3, 3 to 4, 4 to 5. That's 3 seconds. That's width. And then the height here is going to be -3. And that ends up being -9. So the displacement of the car ends up being 12 plus -9, which is 3 meters. And here's what this means. It means if we have like a car, a little buggy traveling, it starts off at the origin, and then for the first 2 seconds it actually shoots forward to 12 meters. That's what happens from here to here. And then what happens is that it reverses direction, and so where it winds up ends up being 3 meters away from where it started. So it starts here and it ends here for a total displacement of 3. Now if you want to get the total distance, what we do is we actually take the total area, the absolute value of everything. We don't worry about negative, we make it all into positive. So in other words, I traveled 12 meters forwards and then another 9 meters backwards for a total distance of 21 meters covered.